Hi, in this video I'm going to discuss uncertainties in fruits. Fruits of course has different model parameters, the consumer or target values, the values of the sources of food groups, the offsets, the weights, the concentrations, and these different parameters are represented in fruits as Gaussian distributions. And of course a Gaussian distribution is characterized by a mean value and a standard deviation value, which is often represented using the symbol sigma. A 1 sigma or 1 standard deviation range represents a 68% probability range, and a 2 sigma range represents a 95% probability range, which means that there is a 95% probability that the value is within this range. Now in fruits, you will of course notice for the different model parameters that one has the value and then the associated uncertainty, and this associated uncertainty represents the 1 sigma, or 1 standard deviation. One question that one can pose here is, what was the motivation behind having the possibility of defining an uncertainty for the target or consumer values? Of course, you could think about measurement uncertainties, but actually one of the main motivations was the fact that you can have also physiological differences among individuals, and even if these are fed on exactly the same diet, these physiological differences will still give rise to uncertainties in the isotopic values measured in the consumer, which are larger than measurement or instrumental uncertainties. For example, I have here some figures and a graph from a couple of studies that performed feeding experiments on animals. So the study by De Niro and Schoninger published in 1983, and De Niro and Epstein published in 1978. In which they observed just this, that animals fed on exactly the same diets had, the individuals had isotopic ranges that were larger than the typical instrumental uncertainty. So for example, mice from this study by De Niro and Epstein, which were fed on the same diet, these are carbon isotopic values measured, for example, let's say in the brain. Well, for these 4 different individuals, there's a range of nearly 1 per mil, which is larger than typical instrumental uncertainty, which is something like 0.2 per mil. And so this was the motivation behind having the possibility of defining uncertainties for the consumer or target data. Now, fruits allows you not to define uncertainty. So, for example, here I could delete this 0.5 and then press apply. But of course, the Gaussian has to be characterized by a mean and a standard deviation. So, which value is being employed here? Well, if you go to model options, you have here minimum uncertainty, and it's this minimum uncertainty value which is being employed to define the sigma of your Gaussian, which is typically a very small value when one considers, for example, carbon and nitrogen, the uncertainties associated with carbon and nitrogen measurements, which are typically of the order of 0.2. Now, the user has the possibility of defining an even smaller minimum uncertainty. The risk here is that if this uncertainty becomes too small, the model may not converge. Of course, this will depend largely on how the model was defined. Another point to consider is if the measurement values are become significant at the same decimal house as this minimum uncertainty. So let's say I had here a value of minus 20.01, which becomes significant at the level of the becomes significant when compared with this minimum uncertainty. Now, what could one do here? Well, one could make the minimum uncertainty even smaller, or one could scale up the measured isotopic value. So for instance, I could multiply this, let's say, by 1,000. What I would have to be sure is that I'm consistent, so my food values would also have to be scaled up by 1,000. But this would generate exactly the same uncertainties and would avoid this problem with the minimum uncertainty becoming significant. So these two options are available, making the minimum uncertainty smaller or scaling up the isotopic values measured in the consumer or in the food values or source values. And this, of course, applies to all the other parameters also. Of course, in fruits we have the possibility of defining priors. And let's, for example, define the following prior: that the consumption of plant foods equal that of terrestrial animals. Okay. Now, what actually fruits does is do the difference between these two estimates, so the consumption of plants or terrestrial animals, and imposes that the difference between the two has to be zero. Well, actually, this is not a vertical line expressing the difference with no thickness. It's also represented as a Gaussian distribution, taking as sigma value the minimum uncertainty, which is defined here, which typically will be a strong prior, and as this would be a very narrow Gaussian distribution. What if we want to associate some uncertainty to this equality? Well, you can do that. There's this option here to define a user-defined uncertainty. You just tick this box, and now we can apply the same prior as before. So the consumption of plants equaled, and now when we press equal, this box that didn't open before opens and allows the user to define a certain uncertainty. Now the estimates, the contribution from food groups, these estimates are expressed between 0 and 1. So let's say I want to have an uncertainty of 0.1. Okay, so this would be, if these estimates were expressed between 0 and 100%, this would be an uncertainty of 10%. Okay, I press OK, and the uncertainty is represented between the brackets, so the 0.1, and then I double click on terrestrial animals. This is my prior, which I could then add, and then I would still have to apply to save. Okay, and what this means is that the difference between the two is no longer represented as this very narrow Gaussian distribution, but as this Gaussian distribution. Remember, the sigma that I defined was 0.1, which means that my 2 sigma is 0.2. So this means that there's a 95% probability that the difference between these two estimates is between minus 0.2 and plus 0.2. One can define other types of priors in fruits. So for instance, let's imagine that I want to define as a prior that the consumption of the food group plants was larger than 50%. Since this estimate is between 0 and 1, actually I should write 0.5, so larger than 0.5. So what one would have is something like this. So I 0.5 here represented by this vertical line, and it has to be larger than, but actually it is represented as a Gaussian distribution with a standard deviation, which again corresponds to the minimum uncertainty. Okay. Now we want to associate an uncertainty to this inequality relationship, and as before, let me erase this. As before, we have to tick on this user-defined uncertainty box. Right. Ticking here, double-click on plans, larger than, and here I can here I have the same box as before, and so I can define an uncertainty. I will again define it as 0.1. I press OK, and we have the uncertainty in between the brackets, and the larger than symbol before and after the brackets, and then I double click on threshold animals, and then I would have to add and then apply to save this private. Okay, and one way of interpreting this, okay, is that now we have this Gaussian distribution with a sigma of 0.1, which means 2 sigma of 0.2. And so this means that there's a 95% probability that the consumption of plants will be larger than 0.3, which is my minus 2 sigma point. Okay, and that's it.